The author of FatScript, the programming language. And tonight I'm going to show how to use FatScript to create a text-based sort of screensaver animation, if you like, that resembles the Matrix rain. Um, that animation that you get like those codes which are kind of falling on your screen all in green. So basically the idea tonight is to try to recreate that, but just using the standard ANSI controls. Basically we're gonna just render out to the screen at specific positions, like updating the screen, like the text-based screen really, and try to get as much as we can in terms of frame rate. I'm not really sure how much we're gonna get out of it, but I think it's gonna be enough for us to have some of that vibe of a screensaver. Okay, so I'm just gonna create first here a brand new folder. Matrix screensaver. And I'm gonna start VS Code. We're gonna use VS Code for today. And just create a new file. I'm gonna call it main.fat. We might have other files. I'm gonna see. Maybe I'm gonna just code everything into one huge file. Let's see. So basically what we need is we need to have first like elements just going through the screen and kind of drawing that sort of rainfall, right? So to do this, what I'm going to do is I'm going to use a sort of particle system. So I'm just gonna call it particle. And in that particle, basically what it has is like a position. So it has a position which is of type position. It also needs a color. And a color for us is just going to be a number. We're gonna come back to this later. Because color is also a name of a library, I'm just gonna call this color pair. Okay, so it's gonna be or simply pair, and we know this refers to color. And I'm also gonna add one thing here, which is like movement, which is going to be a vector, which is something similar to a position, which would have an XY, but in this case, it's gonna be just indicating the movement, right? So now that we are set up to draw particles, I have to still define what's a position, what's a vector, and then we can start creating our matrix screensaver. So basically here for position, that's just going to be a simple X number and Y, which is also number. And then for the vector, I'm also going to represent it as an XY, which is like the movement direction. So I'm just gonna say it's an alias of position. And then so one of the first things here is we're gonna import the standard library. So for doing that, you can just do this arrow to the left, and then fatstd brings you in all the libraries available from FatScript. And And okay, once we have this setup, we need to kind of create these particles with something to draw in. So I'm going to also say what's going to be the character which is going to be drawn, which is of type text, right? So let's just try to render out a simple particle to see if any of this is working, if we have any mistakes here so far. So particle, we need a position, so I'm just gonna say position 5, 5, and then the color pair, we're gonna get to that soon, but for now I'm just gonna do curses dot make pair, and then color dot green. I know we could do better, but then just gonna call this yeah, whatever, C1. Okay, we're gonna have to come up with something better for the colors in the as we go, but for now I'm just gonna create this color. And then for the movement, for now I'm not gonna put any movements, so I'm going to actually put this movement down here. And for the character, I'm just gonna put A for now. I'm gonna change this in the future. And for the movement, one thing I can do here, I can just say if I don't initialize movement, it's just gonna default to vector 0, 0. So it's not gonna have any movement. Basically, that's it. Okay, so now we need a way to render this particle out. So render is going to be just curses.print. So it's a function. This is already a new syntax that is being introduced by FatScript 4, but it's already available to be used also on the Fry interpreter version 3.4 onwards. So when you're creating a function that doesn't take any arguments, you could also do this, but now from version 4 onwards, you will have to call this function like render, like this, to indicate that this is a function. But if you declare it with this double arrow, you're just calling the name will actually execute this block of code as almost like as if it were a macro, or yeah, like a function, but it doesn't take any arguments, and also it won't accept any arguments. That's the main reason why I introduced this distinction. Anyway, this is some news. I'm going into another direction here. Let's focus for now on the task we have at hand. I'll probably make another video before launching version 4.0 with all the new features that I'm planning for the version 4. Okay, so I'm just gonna start already coding with the new syntax, so this video already looks a little bit more modern, and it works both for version 3.4 and there onwards. Okay, so curses print at, I'm going to say I need to extract my position equals self. Also, I need to extract the pair and the char. I need to get all of this, which are properties of the particle. I need to put it in the scope of render function so I can use those. And I say curses print at position this char. Now, one more thing we need to do before that, we need to say curses dot set pair my pair, right? So it basically sets the color and prints using that color. That's basically what it does. And for now, I'm just gonna say p1 equals particle, and then after I create these stuff, I'm just gonna say curses dot clear and p1 dot render, and then curses dot refresh, And if I'm not mistaken, this will already do it, and then I will just call time wait infinity. Infinity. Okay, right. So this will just make it wait forever. You can do this in FatScript. And we can exit here just pressing Ctrl plus C, and it will terminate the program. And so we just execute this so we can see what's going on. Okay, so I'm basically just going to call here, and nothing to call, anonymous at something. So it's complaining about the vector, probably because I didn't define it at that point. So I'm just gonna move these up. I hope this is the reason why it didn't work. So position, maybe this will fix it. Set pair not found. I think it's make pair, maybe the name of the function. Oh, okay, set pair, no, use pair. So there's make pair and use pair. Okay, so that's me not remembering the name of the functions, and I think that now we are all good. Okay, so it created the letter A at the position 5. You have to remember that when you're working with text, the characters actually have double the height as they have the width, and so yeah, basically it would not appear like here. It's much taller than it's away from the left side here, from the left margin. If I wanted it to actually move further into the left and look more symmetric, like into the screen, I have to put a bigger number here, probably the double as the height, which it's like 0, 0 is the position 0, 0 is at the very upper left corner, and then you have like curses max -1 as the y minus 1, x minus 1 is like the end of the screen, right? So this is the maximum value you can actually get is -1. So this would be so anyway, I could start already rendering this at a random position. So instead of doing this, I could just get something that gives me a random value anywhere within the screen. So to do that, instead of calling here 10 and 5, I can just say curses. I can just isolate this first. Screen. Actually, better doing it dynamically, because if we resize the screen, it would still kind of keep working. So curses.get max x, and this is gonna be times math.random. I'm gonna bring this out. Okay, so position 1, and this is color 1, and this is part 1. Okay, so color 1, position 1 is going to be position, and the same thing goes for the y as well. Because random goes from 0 to 0.9999, it never reaches 1. This will actually work. It will never insert it after the screen. Like, it will always place whatever it's printing within a visible position. And now we can just move this here and update the render call to call part 1. And now we can just, each time I run this, it just places the A somewhere else. Okay, so if we do this in a loop, like infinity, and within this infinite loop, instead of waiting infinitely, what I'm going to do is I'm going to actually say that this position is a variable. For now, we will change this as well. So if this position was a variable, we could just change it every time, and then we create this particle. We don't even need to store it, and we just render. Right? For now, I'm using this clear, so this means that it will go away. I will render it for 1000 milliseconds, and then that's it. So every second we print it in a different position. Why I'm doing this? Because now we are gonna start creating those falling characters from these positions. So instead of just rendering them there, it's gonna start there, but it's gonna continue. So for that to happen, I'm actually gonna create a little array, a little list of let's say initiators, okay, or rain. That's matrix rain, matrix drops. Okay, so matrix drops is like the things that's gonna rain, and basically what happens with this drops is it will have a movement by it kind of needs to get updated and move forward, each of them. So we start with it like an empty list, and then when we enter our infinity loop, our main loop, what we do here is we need to create a new particle. So basically I'm just gonna do something here. I'm gonna create a function that returns a new particle. So new random drop, and it also doesn't need any arguments. What it's gonna create is it's gonna use a position which is random, and then it creates this particle at this random position. And for now, it just uses the color 1. We're gonna change this in the future. And also one nice thing it could do is just get a random character at this point. So I guess we could just say alphabet equals, well, we need all the characters here for the alphabet. So what I'm going to do right now is I'm just gonna say, hey GPT, can you provide me with a string containing all ASCII characters, lower and uppercase and numbers, and a few common symbols. Okay, that looks good for me, right? So I'm going to use this as my alphabet. Let me check I'm not doing any. Okay, so this is giving me a little bit of an issue. This is also going to be an issue if I don't wrap it like this. Do we have a backslash? Because backslash is like an escape sequence. So let me check for backslashes. No, we don't have it, so that's fine. So I think that our alphabet is fine, right? And then what we're going to do with the alphabet is just we're gonna take one randomly from the alphabet. So from alphabet, we just grab a at any position, so alphabet size times math dot random. Okay, so all of this, what it is doing, basically it's taking a random position, taking a random character from this alphabet, and it's rendering with the color 1, which for now is just green. Okay, so let's see how this now behaves. It's not rendering anything because now I removed the part where we create a new thing and all of that. Okay, so here we are not gonna clear anymore, so I might just clear before we enter this loop. So curses dot clear, that I can do, but then after we enter this loop we don't clear anymore. We will have to remove the particles one by one. So we just add a new so matrix drops equals new random drop. So it will just generate that thing and add it in here. And for all the matrix drops that we have, we're gonna walk with this thing dot render. Then we refresh, and that's it. So for now they're not really moving, so that's fine. Let's just see what this makes. So it starts creating random characters everywhere in our screen, but they are still not moving. But that's kind of fine for now, because we first need to make them move now. Okay, so to move them, we need to provide a movement, and the movement is gonna be basically the gravity, which I'm just gonna make it be like, I don't know, 1. We might do it in a better way in the future, but for now I'm just gonna say each particle of this one moves 1 down, so 0 and 1, so it just goes 1 step down every time. So I'm going to provide the gravity here as the movement. And one thing we need to do aside from, well, and here before we print, one thing we could do is we can apply the movement and save it back. Okay, so here at the render, we don't need to return anything. But one thing we might want to do is just say, okay, self dot position dot x we might need to make these x and y variables, otherwise we cannot change them. So position dot x plus equals movement dot x, and position dot y plus equals movement dot y. So now basically we're just adding, every time we render, we are adding the movements to the position, and after that we extract the position and do all the rendering part. So let's see how that helps, if it helps. I guess we will start already drawing those letters. No, they're not moving. They're still not moving. Okay, they're still staying at the exact same position. Because why? Why are they staying at the exact same position? So we're providing gravity here. Gravity is a vector of 0, 1. And position.y gets the movement, which is in self, so self movement. I don't fully get why it doesn't work. Then after we did this, we get this position. Okay, I need to look into what's going on here. So I'm gonna break at this point. So basically what we have here is we have self, which I want to inspect. So we have a self which has a position of 90. And if I execute this code again, like self dot, and then I execute this thing, and this thing, now if I get self again, you see that the y has been changed from 7 to 8. So I'm actually puzzled as of why we don't get these particles being updated when we call render. So matrix drops, walk, render. I guess because the position itself is something that can't change. I guess we need to update the position. Maybe that's the reason. I'm not really sure. I think because of the fact that we are not, let's try a different approach. Instead of making the numbers here be changeable, let's update the position as a whole thing. So we just create a new position. Right, self, movement, self, movement, self. Okay, we don't need this, we don't need this. Okay, this is gonna be X, then the other is gonna be Y. And let's see if this helps. So I'm changing the position in self, I'm explicitly saving the new position where I'm using these stuff to indicate that I want to add them to X and add this to Y, and then I extract it later on. So let's see if this helps. Right, looks like something is not working as expected. So we're just adding these new random drops into matrix drops, and then when we call walk render, I guess the problem is this is not expected to create any effects. Maybe I need to really return like new let me stop this. I need to return the updated versions of these matrix drops. So I'm gonna use map here. I'm gonna say matrix drops equals the new matrix, the new particles after they are rendered, and then here at the end I'm just return self, which is the updated version of all of that thing. So hopefully this would actually do what I wanted. Yeah, it looks like it's now already going down. Yeah, right. Okay, so we start to get the feel for it. I'm gonna make it slightly faster so you can have a better idea. I guess the only problem we have right now is that apparently it's not drawing the first position, or it's starting one below from where it should have started. Okay, well, anyway, one thing I guess I could do is just move this elsewhere. Like just say, yeah, self position equals, I don't even need this, we already extracted the position X, and then I can even extract this here, movement, and then I just say, yeah, movement. I guess this will be cleaner if I do it like this. We don't need to break. So basically we just print the character at current position, then update and prepare for next render, and return updated particle. Yeah, okay, so supposedly this should do now. I'm going to just break this down just so it gets a little bit more readable. You don't actually need to do this, but it's just for a matter of looking a little bit better. So our alphabet is what is in these parentheses. And then one thing we need to do is do some sort of decay, and for that what I'm going to do is these drops, they are not going to be re-rendered, but we also need to, when we create a new random drop, we could actually update it before here and then print. So every time that we create a particle, it's already going to render at the next position. No, that's actually not right, so we need to keep it here where it was. The thing is, we're going to have the matrix drops, and we're going to have the matrix trails, which is like that trail that keeps from what is like falling down. And those ones are not going to get any movement, but they will need to have some decay. So use decay boolean equals false, but for those cases we're gonna add them with decay, right? So so we create this new random drop, we add it to the matrix drops, we render, but I'm going to separate this. So my new drop equals new random drop. and I'm going to add this one here. Then we render. So the old drop, I'm gonna create a new function which is convert drop to trail, which takes as an argument a drop, and it outputs a new particle which is actually a trail. We are not going to type them, just using the same thing. I added that boolean there, so we just know that for the new ones they just use decay, right? So we create a new particle, and then for all the properties, position, pair, char, movement, and new decay, let's check what we're going to do. So for position, we just use drop position. For the pair, just we can start with drop pair, but we will have to iterate over it later on. Char is drop char. Movement is gonna be vector 0, 0. We could even use just a single thing, which is no movement. So we don't instantiate a lot of objects for no reason, we just use the same. So movement is no movement. Use the k equals true, which means the color, we are going to change the color. So now that's where we get to the color parts. And for that thing, we also need to do, okay, matrix trails equal plus equals now convert drop to trail my new drop. Okay, so it's going to add that, and then for the matrix trails, we're also going to matrix trails equals matrix trails dot map render, which actually we should do only on the next iteration. Because like the first you create a drop, it then will move down the next moment, and after it moves down, then it's the right moment to actually draw the trail. So I'm creating it here, but I'm gonna draw it only on the next iteration, right? So this might make sense. And for the render, we still need to make the part where if it has a decay, we need to sort the color out. So okay, so our colors, we will need a gradient here, right? So for that reason, what I'm going to do is I'm going to create an interval here. Instead of using just green, I'm just going to say shades equals from. So I will just use like 10 different shades, not like a lot of different shades. So instead of going from one by one, I'm going to go by 25 by 25. So we do have like 255 shades and theory, I'm going to just jump 10 by 10. And what I'm going to do here is, I mean 25 from 25, so I'm just going to go from 0 to 10. So that's actually 11 colors. And in fact, I think I'm going to do the opposite. I'm going to go from 10, so the strongest color, to the lowest brightness, which is 0, which is basically just black. And with that, like, which is the intensity, so I'm going to take this factor and I'm going to create here curses 2, 2, 5, 6, and then it takes parameters like red, green, and blue, right? So red is gonna be 0, green is gonna be factor times 25, and blue is also just going to be 0, right? So this is gonna give me, the first color is gonna be pretty much as green as it gets, and then we get shades of green up to 0, which is like the dark, completely black. Maybe we'll need to adjust this because we're not printing to a black screen, we're printing to the console, so it might not look exactly what I was intending for it to be, but well, let's try it this way and see where we get with this. So basically now we don't have a color 1, we have shades dot head. Even I would start doing a different thing here. We are using a number, right? So basically I just going to, instead of actually getting the color at this point, I'm gonna execute the shade at another moment. So here I'm just gonna start with shade 0. So even because I don't use that, I could just move it down, and I don't even need to define the color. So if I just put pair, which is the color after movement, we don't need to define it when we are creating a new drop. Don't need it here. We just say it's 0. And yeah, so when we are going to use the pair, we don't use just pair, we use shades pair. So it's gonna get that thing in the shades. If we update color has decay, so has decay, use decay, I guess this needs to happen before. Well, I'm just gonna update the decay here after the particle before it's returned. So update color if you use decay. So if you use decay, what we're going to do, we're going to do something very similar to this case, but I'm testing first if you use decay. And also, if because we only have shades which go from 0 to 10, so we basically 10 is the greatest number that it can be. What I'm going to do is, if the pair is less than 10, then I'm going to apply the decay. So now what we're going to do is just say self. We need to allow changing this color. pair plus equals 1. So if it can be updated, we update it to the next color, and that's the color we're going to use to print the trail. And we have no movement on it, so it's just gonna stay there, and like the color is gonna be reduced. Now, one thing I think we should do is, before we return the particle, we should kind of remove it from scene. So what I'm going to do is, or I don't need to check this, I actually can check this elsewhere. So if the pair is less than 10, less or equals 10, we can still render it. And self position dot x action dot y is less than the maximum which we can actually render, then we can continue rendering. Otherwise, if you don't know how FatScript works, if you don't need to provide here the other option, it just will return nothing. So it will just remove it from the list. So it will just actually work as a filter. So if it doesn't belong to these options, it's just filtered out, and we remove that particle. So we won't bloat the logic, like we will be creating particles, but at some point this will balance out and we will stop creating new particles to be updating on the screen. So okay, I think that's been a lot of coding. I think we can now try the code out and see if we don't have errors or how far we got. Okay, can't resolve scope of 2, yeah, forgot that one. Not found 2, it's not curses, it's color. Okay. New drop. Okay, it's can't resolve scope of position main. Okay, that's a bit weird one. I didn't quite get what happened there. Can't resolve the scope of pause. Okay, so it seems that when I'm trying to convert to trail my new drop, it kind of doesn't exist anymore, maybe because I removed it here. Okay, so maybe I need to do it before. Let's try this. Now I think this screen is having very little color output. So let's try this on a different terminal emulator, like fry main. Can't resolve scope of position at main 61. So somehow we are trying to say convert drop to trail my new drop, and this my new drop is returning is blank. It doesn't really make any sense to me. I'm not sure why this is happening. But then one thing that we can do is just say, okay, if there's no drop, then there is no particle, and that's it. Okay, that's still not good enough. So I think that the problem we have right now is because the colors we are using is 200 and... So I think we need to use, there's another method here, which is the 24 bits. So this is like the true color version. Maybe it's not like that, 24 bit. Yeah. But the strange part, we are just creating one of them, and the others are not being created like that. Okay, but now at least I think we're getting somewhere with this. I think I know. I think we actually need to convert all the matrix trails into new drops. So matrix trails is gonna get added by all of these ones. So this is a little bit heavier thing. So for all the matrix drops, we need to convert that drop to this thing, and then we render the drop. I guess this should fix. I think we're not doing anything here. Let's just make sure that this code is actually executing in the order that we expect it to do, and I'm going to also do it like this. I think I need to do it like this, not 100% sure. So it receives an argument, it passes whatever are the matrix dots one by one into converter. Yeah, you could also have used the map here. But anyway, this will do. You can use a map. I think it's more elegant, maybe. So we add all the drops that have been updated, No. Yeah, they already have been updated at this point. So yeah, okay, I guess this should do it. Well, it's almost working, but the first character is still standing there. So that's a weird one, which I'm not really sure why. But let's look at the code. So we basically are adding to the trails all the new drops, which have already been updated. I think the problem is with this rendering logic here. I guess we need to update it always before we even start. And for that reason, because we are always moving down, like +1 on y, I would start at -1. So whenever we try to render that thing, it kind of might just... So y times random -1. I guess this would actually fix, so it will use the full size of the screen. Can't resolve scope of x, where at 21. Is there a problem with this thing? No. has nothing to do. What did I change before that? Oh yeah, of course. So it can't find movement. We can just extract before. Now the position, we can just say self position, self position. Now it will do everything right, I guess. But the thing that is not happening is that the other ones are not kind of changing characters. So we still need, as it moves down, it needs to change which character it's going to render. So that's, I think, is the final part to get something that looks marginally like some matrix kind of thing. So here, if it uses decay, it just changes the pair. But if it doesn't use decay, then it will do something different, which is it will re-choose a new character. Just gets a new character. So I'm just moving this out. So the alphabet is just defined as a global, and this one, which we can also call like a function, I'm not create a function for this. I'm just gonna call it directly, and I'm just gonna define it here too. It's just such a simple operation. I don't think it's worth creating a function for it. Okay, so still not working. Need to understand why. Yeah, we didn't say anything. So self dot char equals a random new one, and we need to allow also char to change. I guess now it will look more like matrix. So the thing it has written is replicated to the previous position, and it writes something new on the next position. And then, yeah, that feels already very much like matrix. And I guess that's basically it. And yeah, I mean, we can just now try to remove all the delay that we have added. And let's see how this behaves. I'll just let it kind of wait just 10 milliseconds before it tries to render the new one, and we have a very fast moving matrix kind of effect. Maybe even too fast. We could just maybe put here, I don't know, 25, and now it will look kind of sort of cool. And we have that vibe of like a screensaver that looks a little bit like the matrix effect. One thing that I'm noticing is that when we remove the character from the screen, we still should kind of erase it because we get like this black trail that is left over. So return updated particle, and I guess the thing is, so this is like different options. So if the pair is more than 10, then we will do one thing, which is we'll just erase it. And for that, we're just going to use curses print at the same position. Just print a blank space, and that should remove it. Otherwise, if self position is less, then we return self. Otherwise, we don't need to define it, because the next definition would be we don't return anything, we don't do anything. And this is a function that returns void. So also for this case, it's not returned. We erase and we don't return it. So that should actually fix the final bit. So when it's too dark, it gets kind of black, and then it's removed from the screen, it's erased. And I think this is kind of neat. In my opinion, it already looks it feels very much like a Matrix sort of screensaver. And look, we are just using the terminal characters at this point. So I hope you enjoyed the process of creating it. I know it really showed up how it would look like at the very end. And it's something I always wanted to do, like creating this kind of matrix effect. And I hope you have enjoyed the process. If you have any doubts about how I did it, if any of the parts of the steps which we were following didn't get very clear, or you have any doubts about the language itself, about FatScript, just please put your comments on this video. If you have liked, then give a like to this video. And I'll probably also try to get this source code and put it in GitLab and publish it, and come back to this video and add as a comment how was where you can find it. All right. Okay, so that's it for today. Thanks for watching, and we see yourselves on our next FatScript session.